Hi everyone, my name is Joe Eames, and welcome to my course, Getting Started with NPM. I'm a front-end developer, teacher, and author. Learning NPM is important because it is one of the most widely used developer tools, and the concepts behind it are very valuable to just about every developer. In this course, we're going to learn the basics of using NPM in your daily workflow, advanced topics like auditing and dealing with specific versions, and finally, how to create and publish our own packages to the NPM repository. By the end of this course, you'll know how to do everything with NPM to get your job done, and use NPM to its fullest. Before beginning this course, you should be familiar with using a terminal. I hope you'll join me on this journey to learn NPM with the Getting Started with NPM course at Pluralsight. Hello, I'm Joe Eames, and welcome to Pluralsight's Getting Started with NPM course. I'm excited to present this course to you. I've been doing open source development for quite a while now, and NPM is one of the basic tools used in almost all open source and front-end development. It's the package manager against which all package managers are measured, so it's definitely a tool with which all open source and web developers need to be familiar. This course is organized into 3 different parts. We'll start by looking at the basics of NPM. This includes not only the basic commands, but also the basic usage of NPM, the type of things you'll do on nearly a daily basis with NPM. After that, we'll look at some advanced topics with NPM. These are the topics you probably won't use very often, but they're still good to know about because under certain circumstances, they can be very valuable. Finally, we'll talk about publishing your own package with NPM. Most of the time when we're using NPM, we'll be building a product for users, but occasionally we may want to build a product for other developers to consume. And an easy way to do that is to publish that code through NPM so that other developers can easily add it to their own projects. This section will show you exactly how to do that and how to keep it up to date. And with that, we'll get started with our course. It's useful to understand the difference between a package and a module. A module is a single JavaScript file that has some reusable functionality. A package is a directory with one or more modules inside of it, and a package.json file which has metadata about the package. A package can be very simple. For example, underscore just has a single JavaScript file. We see the 2 versions of it, the regular version and the minified version, and a package.json file. Whereas a more complex package, like Express, has one JavaScript file in the root, but inside its subdirectories has quite a few more JavaScript files and more within subdirectories of that. So this is a much more complex package. Now it's very common for people to refer to a package as a module, so you shouldn't be confused or thrown off when somebody does this. But when we use NPM, we're actually working with packages, which is why it's called the Node Package Manager. One of the common things you'll use NPM for is to look at other people's sample or starter projects. When dealing with projects like this, there's a very typical flow that we'll go through. The first thing we'll do is we will clone the project using Git. Once we have the project cloned, we'll move into the directory, and then we always install using npm install. This will install any dependencies noted in the package.json file for that project. Now that we have everything installed, we want to see it in action, and we'll do that using the npm start command. This is only going to work if the project that you downloaded has created a start script. To determine if a project does have a start script, you can just open up the package.json file. Here I'm showing the package.json file for this project, and you can see in the script section, we have a start script and a test script. Let's run that start script. In this case, this project starts up a server running on port 3000. Another typical thing that we want to do is run the test for the project, and we can do that with npm test. Again, this only works if the project has created a test script, but if it does support tests, then there's a good chance that they did create a test script. Oftentimes, we don't care if the tests are passing unless the demo is specifically about testing, so frequently we will skip this step. And that's the typical flow we use when dealing with sample and starter projects. Getting help with NPM is actually pretty cool. You have several options. Obviously with NPM, just like most command line utilities, you can do npm-h, and that will give you a list of the typical NPM commands and some minor information about them. You can also do npm and then a command, for example, install, and -h, and that will give you more information about that specific command, usually just the different kinds of usage for that command. But there is another option that's very cool, which is npm, help, and then the command. This will actually open a browser to the official help page for that command on NPM. This not only gives you the syntax, but also a lot more information because the help documents are a lot more complete than just the command line help that you can see. There's one specific help document that you should be aware of, and you'll probably want to refer back to multiple times, and that is right here, the miscellaneous config page. The reason for that is that if you scroll down on the page, you will come to a list of shorthand commands for NPM. This is really nice to refer to frequently so that you can learn and memorize the shorthand commands for the different longer commands in NPM. And this doesn't actually list out all the shorthand commands. It lists out all the shorthand for the flags, but there are other shorthands that aren't listed here. For example, npm install can be shortened up to just npm I. So not every shorthand command is listed on this page, but a whole bunch of them are, and it's really convenient to be able to refer back to this whenever you need to. When you're working with NPM, there's really 2 kinds of projects you're going to be working on. The first one is going to be your typical project where you're building something for users. It's a website, a web application, something of that nature, where there's going to be users that are using it of some kind. The other kind of project that you deal with NPM is a third-party package, something you're going to build for other developers to consume. We'll talk about building packages for third-party consumption later on, but for now let's talk about the first kind of project, a project you're going to build probably for other users or yourself to use. With this kind of project, there's a couple of reasons that you'll want to create a package.json file. The first is to track the dependencies of the packages that you're using. So whatever packages that you download and install through NPM, you'll want to keep track of those. And the other reason is it's a quick and easy way to create some little scripts. This will help you avoid having to install Grunt or Gulp just to save you a little bit of typing every time you want to start your project up. We'll talk about scripts later on, but for now let's talk about just creating the package.json file. The command to do that is npm init. This command is going to walk you through a series of questions. Now those questions are going to change as versions of npm change, so you may not see the exact same questions that you'll see here, but even so the differences will be fairly minor. One nice thing about npm init is that it will give you defaults for every answer, so nothing is truly required. You can just hit enter at every point and create a default package.json file. Now the nice thing about the fact that it gives you all these defaults is that these questions really don't matter. If you're not publishing this as a package in npm, then this information is completely for your own benefit. If you publish your project on GitHub, other people may see this information, but the accuracy of this information really isn't going to make a difference. So for the name, I'm just going to accept the default here by hitting enter. Version 1.0.0 is just fine. Description, I'll just leave blank. For the entry point, I'll accept the default. default, test command, default, git repository, default, keywords, default, author. For this, I'm going to fill in my own name just for vanity purposes. But again, this really doesn't matter. License will accept the default. At this point, it actually shows me the package.json that it's going to create. And one thing that you'll notice is it's a little smart. I've already installed Express, and it's picked that up and put that into the dependency section for me. So if I create this package.json after I've been developing for a while, whatever packages I've already installed are going to show up there in the dependency section. Then I just hit enter to accept this as being okay, and my package.json file has been created. Now you can always create a package.json file by hand, but I find that it's so quick to type in npm init and then just hit enter a whole bunch of times, have it create my package.json file for me. And if that's all you're going to do is just accept all the defaults, there's actually a faster way. If you type in npm init and -y, then npm will quickly create a package.json file for you with all the default answers accepted. Installing a package with npm is pretty straightforward. We just use the npm install command, and then we give it the name of the package we want to install. Now, most of the time, the name of the package is probably the name that you refer to that product. For example, if we want to install Express, it's just Express. If we want to install Lodash, that's Lodash. But sometimes the package names don't actually match with what we call them. For example, there might be, theoretically speaking, a package out there that represents an ion drive, which could be useful in taking a trip to Mars. And internally, they might just call that product ion, but because the word ion was already taken, we actually have to install it using ion-drive. In order to find out what the name of the package is to install, generally it's best to just go to the package's homepage and look for their setup instructions. Now, if we were to install something like Express, after that's been installed, npm will automatically add it to our package.json file. And you can see that listed here. It's been listed in the dependencies. This is an automatic thing. We don't have to do anything extra in order to get that functionality. But if we wanted to install something into the dev dependencies section, for example, JS hint, then we'll need to use another flag to tell npm to list it in the dev dependency section, and that is -save, -dev, or for short, you can use -d. And now we can see that that's been listed in the dev dependency section, and Express is still listed up in the dependency section. Now that we've installed a couple of packages, you may or may not have noticed that there is a new file that has appeared in our directory, and that is the package-lock.json file. That file got created when we installed some packages. If we were to look inside of the package-lock.json file, we will see a lot of JSON. And what all this data is actually specifying is the exact versions of every package that got installed. There's a very important reason for this. Let's say that you have installed the ion-drive package, and the ion-drive package actually depends on the particle package, the accelerator package, and the navigation package. And so when you install ion-drive 1.8.2, it installs particle 2.1.0, accelerator 1.1.4, and navigation 0.7.1. But a few days later, one of your coworkers installs that same project, and when they install, they actually get particle 2.1.1 because a new version has been released in the time since you installed. Now there's a difference between your two installation directories, and that can sometimes run you into trouble. And so the package-lock.json file's purpose is to specify exactly what versions were installed, and you check that file in source control, and everybody else uses that same package-lock.json. When they do the typical flow of just running npm install, it will look at the package-lock.json file and install those specific versions. And that makes sure that everybody on your team is running off the same exact versions of all packages, so that you don't get any weird issues where something works for one person but not for another. When we have some packages installed, we often want to find out what packages are actually part of our project, and npm provides a list command for that. So if we just type in npm list, we'll get listed out all the packages that we've installed, plus all of their dependent packages. Now, if I scroll through this list, you'll see that this is incredibly long, but yet if we look at our package.json file, we can see that I've only installed 2 packages, Express and JS hint, and yet just those 2 packages have installed a lot of other packages. So oftentimes using list can be just an incomprehensible mess. Thankfully, there's quite a few different arguments you can add to the list command to make it a bit more usable. For example, there's a depth command, and this specifies the number of levels deep you want to go. So if we want to just see our 2 libraries, Express and JS hint, and just the packages that they directly depend on, we can use a level of 1 for depth. And that will then show each of the 2 main packages that we've installed, Express and JS hint, and just what they depend on. The most common, by far, usage of this is to do depth of 0, and that will just list the ones that you've directly installed. In addition to that, there's a long flag, which will print out a lot of detailed information on each of the libraries or packages that's getting shown. So you can see here what that looks like. There's also JSON, which puts it out in a JSON format. There's a parsable format, and you can see that basically just lists out the directories. We can also limit one of these to just our dev dependencies by putting -dev, and we can limit it to just our production dependencies, our regular dependencies, by using --prod. And finally, when doing this command, there is a very common alias for it, which is npm ls. There are times when you'll need to install npm packages globally. The reason for this is not to be able to avoid having to install them in every project that you need that package, but instead this allows the package to create a command that can be used from the command line. For example, if you want to run gulp, you're going to need to install it globally, otherwise the gulp command doesn't work from your command line. So in order to install a package globally, use the same command, npm install, the name of the package, and then you use the -g flag. This will install the package globally. When a package is installed globally, it doesn't get installed into the node module subdirectory of your current directory. Instead, it goes into a special directory on your computer. So if you want to know what global libraries you've got installed, instead of locating that directory and looking at the contents of it, it's much easier to use the list command, adding the -g flag, and then of course you want to use a depth of 0, so you just see the libraries you've installed. Now that we've installed some packages, we might want to uninstall some packages too. And that is, as you would expect, done with the npm uninstall command. And of course, we give it the name of the library we want to uninstall. So if we want to uninstall Express, we just do it like this. And at this point, it's been removed from our node modules directory and also from our package.json file. There are a few aliases for npm uninstall, and those are npm rm, npm un, and npm r. And lastly, if you want to uninstall some package globally, you're going to have to add the -g or --global flag in order to uninstall it from your global node package repository. Most of the time when we install a package, we want the very latest version, and that's what happens when we just give the name of the package. In this case, if I install underscore, I'm going to get version 1.8.3. But there are times when you want to install a specific version of a package. This is especially important in critical applications where updating a package to a new version might break your product, and the consequences could be catastrophic. In those cases, you want to make sure that you're only installing specific versions of libraries. This is particularly important in mission-critical applications, but it can be important in other kinds of applications as well. When dealing with specific versions of packages, it's important to understand semantic versioning. Semantic versioning is a system of versioning whereby each of the three numbers means something to everybody and not just to the developers who decide what the three numbers mean. So in the case of underscore, which is currently at 1.8.3, each of these numbers means something very specific. 1 is the major version, 8 is the minor version, and 3 is the revision or patch number. We'll start with the patch number first. The patch number is only incremented when you make something like a bug fix or performance improvement to a product, something that doesn't change functionality. So for example, if there was a bug in underscore that they fixed, or a new performance improvement, they might revision it to 1.8.4. Meanwhile, the minor version means that there are new features involved. So if a new feature was added to underscore, then we update the version to 1.9.0. In this case, no existing functionality is broken, but new functionality is added. In the case that you actually break functionality and do something that's no longer backwards compatible, that is the time when you update the major version. So if underscore were even to do something as simple as change the signature of one of its functions and reverse the parameters, that would break existing code, in which case our 1.9.0 would now become 2.0.0. Understanding this, we can now understand how versioning works with NPM. In NPM, if we want to install a specific version of a package, we can just use the install command with the name of the library, then an @ sign, and then the number of the specific version we want to install. So in our case, we might want to install 1.8.2. But we can get a lot more complex than this. For example, we might want to install the latest version of 1.8, in which case we can change the 2 to an X, or we can just delete the patch number itself. In this case, underscore will install the latest version of 1.8. If we change this to 1.7, we will install the latest version of 1.7. If we change this to 1.x, then we'll install the latest version of underscore 1, which at this point would be 1.8.3. We can also just remove the .x and get the same functionality. But we can be even more complex than this. For example, by introducing quotation marks, we can use things like a greater than sign and then give a version number. We can say that we want anything past version 1.1.0. This would not include 1.1.0 itself unless we added an equal sign. We can also say that at the same time we want anything before 1.4.0. This will in general install the latest version of 1.3. We can even get more complex than this by adding in an OR operator and another range. But in most cases, we really don't need all this functionality. There are three main cases we want to handle. The first case is to simply install the latest version of a library, which we do with syntax like this. The second case is to install a very specific version, which we do like this, by adding the version number after the @ sign. Finally, we might want to install the latest in a specific major version. For example, Express is currently on version 4, and if we wanted to install the latest version of Express 3, we could say anything before 4, or 3.x, or just 3, and that would give us the latest version of Express 3. And if we know that Express 3 works, we can trust the authors of the library that they won't break any functionality in any version of Express 3. Now, if I just want to install the latest version of underscore, then my package.json file will be modified. We can see that underscore has been added as a dependency. But this little caret right here means that if underscore publishes a new version and goes to version 1.8.4 or 1.9.0, the NPM will install that latest version and not 1.8.3. In most cases, that's just fine. But if I want to install a specific version of underscore and not let NPM upgrade me to the latest version, then when I install underscore and give it a specific version number, but I'll also need to add the --save -exact flag. If I install like this, now my package.json lists 1.8.2 without the caret. That means that NPM will only ever install 1.8.2 for me and not automatically upgrade me to a later version of underscore. This is the kind of thing you want to do on mission-critical applications with large teams where you only want to upgrade your dependencies to newer versions under very specific circumstances after evaluating and testing that the new dependencies don't break any existing functionality. It's very important to understand how dependencies are installed based on what's specified in the package.json. So we're just going to take a quick minute and look at a couple scenarios. Let's first install a simple library like underscore. And notice that it reports out to us that we've installed 1.10.2. If we go and look at our package.json, we can see that it's specified 1.10.2 with the caret. Now let's remove the node modules directory, and let's also delete our package lock file. And we're going to go back into our package.json. Let's change this to 1.8.0. We'll save that change, come back, and now we're going to install with npm install. And what do you think is going to happen? Let's look and see what actually got installed. All right, you can see there we have underscore 1.10.2 still. It's because of the caret that we're getting the latest minor version of underscore. 1.10.2 at the current time is the latest version of 1, so we're getting that. If we want to get the latest version of 1.8, we've got to change this caret to a tilde, and we'll go back to the command line, and we'll remove our node modules directory, and the package.json file, and then we'll install, and let's see what version we have now. And so now we're getting 1.8.3, which was the latest minor version of 1.8 because of the tilde that we used instead of the caret. Now notice every time I had to remove the package.json file, that's because whenever you install, if there's a lock file, it's going to use whatever's specified in there and ignore our package.json file. That's very important to understand. You can end up messing around forever with your package.json file, and as long as you still have a package lock file, it's just going to install whatever's specified in there. Now, if I just want the latest version of underscore, and I don't care whether it's a minor version, a patch version, or even a brand new major version, then the way to do that is to change this whole thing to either an asterisk or an X. Either one will let me install the latest version, no matter what it is, of underscore. We'll install really quick and list again, and we're back to 1.10.2. Understanding these things about how the package.json file works and its specifications, those are really one of the key parts of working with NPM. One of the great features of NPM is the ability to easily update your dependencies to the latest version. Here in this sample, I've got a package.json file that specifies that I've got underscore as a dependency at version 1.8.2 and JSHint at version 2.7.0. Both of these have a caret, which means we can update to the latest minor version, but we're not going to update to a new major version. I've actually got installed versions 2.7.0 and 1.8.2. Now, both of these libraries have a newer version than this. So in this scenario, we installed these earlier on, and now they've been updated to a newer version. With NPM, whenever I want to update to the latest version, all I have to do is type in npm update. At that point, NPM goes out and grabs the latest compatible version of all your dependencies and updates them. If I now check and see what I've got installed, we can see that I've got JSHint 2.8.0 and underscore 1.8.3, which is currently the latest versions of those two libraries. After you've used npm init a few times, you'll find that there are several settings that you'll keep the same every time. Using the npm set command, you can set some defaults for npm init. For example, if you want to set the author name, you can use npm set init -author -name, and then put in your name as you'd like it to appear. To get a list of these defaults you can set, if you go over to the npm documentation under using npm under the config section and search for init-, you'll find a list of these settings. There's an init module which isn't useful, author name, author email, author URL, license, and version. We've already set the author name to a default. Let's also set the license. We'll set this to MIT. And now if we use npm init and we just accept the defaults, it will include our author name, and the default for the license is now MIT. If you want to check and see what one of your settings was set to, you can use npm get and the name of the setting you want to check. If you'd like to remove a specific setting, you use npm config delete and then the name of the setting. The reason we have config in there is because the npm set and npm get commands are actually short for npm config set and npm config get. All these settings go into your npm-rc file, which is in the root of your user directory, and we can see this file by looking at the root of our user directory, and that's where all those settings are contained. Let's talk about installing packages from GitHub. When you find a module on GitHub that you want to use, almost all of them will tell you the command to install them. Here is the GitHub repo for Express, and you can see right here the command to install it using npm. But what if you found a module on GitHub you wanted to use, but it hasn't been published to npm yet? Or what if you forked somebody else's library and made some changes that are specific to your business? Maybe you want to run an Express web server on the next Mars rover. Or what if you wanted to try out some unreleased features of a package? You can do that by giving npm install a URL instead of a package name. For example, this command will install not the latest published version of Express, but instead the current head of the repository. So whatever the last thing that got checked in is, you'll get it. And one thing to note is that this actually isn't limited to just GitHub. This will actually work with any URL that has a package at the URL you give it. So for example, if you have a private package that you have on your own server, you can just give npm install the correct URL, and npm will happily install a package from that location. You can even install a package that's been published on Dropbox. Just give it the URL, and npm will install it from that location. Sometimes we need to install a gist as a module. This can happen when, instead of forking an existing package, you create a gist out of it and make some changes. And then you want to test those changes as a dependency of an existing project. Here I've created a very simple gist with just two files, an index.js that does nothing more than log out the message hello Mars, and then a package.json which has the basic information about this package. Notice that every gist has a hash up here in the URL. If we copy this hash, then go to our project and type in npm install gist, a colon, and then paste in the hash, this will actually install that gist as an npm package. Now it's very important that the gist itself have the package.json. This will not work without it. And if we look at our package.json, it's listed there, but instead of a version number, we see that it's a gist with a hash. Sometimes you may need to install packages that are private and not published to the npm registry. This is more common in larger organizations which may have a very large software base of closed source software that they don't want published to npm, but they still want to create components as packages and allow other developers to be able to use those packages and install them just like regular packages from the npm registry. A great way to do this is to create these packages and then store them on a shared folder somewhere on the company's network, or put them in Dropbox and then use Dropbox to sync them up on a developer's computers, or even publish them to a private website. In the case of publishing them either to shared drives or using Dropbox's folder sync option, the package is going to be in a folder somewhere on your computer and you want to install from that location. npm is just fine handling this. It can install from a folder somewhere else on the same computer, or even from a network drive. All you need to do is give npm install the path to the folder. In our case, we're going to install our hello Mars package from a sibling to our current directory. This has successfully installed that package, and if we list our packages out, we'll see hello Mars is listed. The npm registry is basically just a big huge list of every package that has been published through npm. The main piece of the registry is the package.json for each package. When you go to npmjs.com and search in this find packages box, you're actually searching through the registry. Once you select a package, you're seeing the registry information about that package. There's a couple of other things you can do with the registry that can be useful. For example, if you go to registry.npmjs.org and type in the name of a package, you'll actually see a JSON version of the npm information for that package. Another nice thing you can do is if you type in npm.im/the name of package, it will take you directly to the page for that package. This can be really useful when you know the exact name of the package you want to see, but you don't want to take the extra time to go to npmjs.com and use the search box. npm has a search feature that's just npm search, and then any keywords you want to search for. Say, for example, you want to search for packages that are related to underscore. This will search for any package with the word underscore either in the package name or in the package description. Unfortunately, the npm search facility can be quite slow, and the results aren't necessarily the most useful results you can get due to the fact that you're looking through a lot of information on the command line. The search function searches the NPM registry. Thankfully, there's another way to search the NPM registry that's actually quite a bit better. If you just go to npmjs.com, there's a search box right here that you can type in a search phrase, and not only will it give you suggested results underneath it, but if you hit enter, then it will search and list all results. And if you search for something a lot more specific, like underscore mixins, you get a much more limited set of results, and they come back instantly, and now you can go and click on one of these results and see the detail page for that particular package. Sometimes in really large projects, you install packages that you don't mean to install, or you stop using a package and want to remove it, or maybe you try out a package and decide that you don't need it. You can always use the npm remove command, but if the package isn't specified in your package.json file, either because it was never in there, or you deleted it from your package.json file yourself, then you can use the prune command instead. Let's go ahead and run an npm list with a depth of 0 on this project, and you can see that I've got grunt, jshint, and underscore installed, but you'll notice that there's an error that npm is reporting that grunt is extraneous, and next to grunt is this little green extraneous. This means the grunt is not specified in our package.json file. Indeed, if we look at it, we can see that we've got underscore and jshint specified, but no grunt. So if I were to run npm prune, npm will go through, compare the packages I've got installed with my package.json file, and remove anything that shouldn't be there. And now if we list out our packages again, we're clean. You can, with npm prune, add on the name of a library, like grunt, and then it will prune just that one, but that's essentially the same as doing remove. The other scenario that prune could be useful in is when preparing to deploy to production. In that case, if you add the -- production flag, this is going to remove all of your dev dependencies, which will leave your package ready to go to production. You can see this remove jshint, and now the only package that I've got installed is underscore, which is the only one that's specified in my production dependencies list. Sometimes when working with a package, we want to go and see the official website or go look at the source code for the package. That's where the npm repo command can come in handy. Repo works by typing in npm repo and then the name of a package. In this case, let's do underscore, and that will ask npm to take you to the official repository for that package. So you can see it's opened up a browser and navigated us directly to the underscore repository. From there, I can look at the source code, I can go down and get links to the official website and other information. So this will be really handy. Of course, you can usually find the same thing by using Google, but sometimes, especially for more obscure packages, this is a lot easier than trying to find it with Google. You may at some point discover that you need to upgrade npm itself. This is actually fairly easy because you can install a new version of npm just exactly as you can with any other package by using the npm install command. There's just a few things you need to keep in mind. The name of the package is npm, of course, and to be clear, we'll use @latest to get the latest stable version of npm. It's a global package, so we have the -g, but most important, you must run this with administrator privileges. You'll notice that I'm in a plain Windows command prompt, and at the top, it indicates that I'm an administrator. Especially in a Windows box, if you do this without administrator privileges, it possibly can mess up your entire installation, and you'll find the only remedy is to reinstall Node itself. So as long as you do that, then this is the command that you can use to upgrade npm. The ability to write your own scripts using npm is a very useful feature. One of the nice things about it is that npm supports simple scripts, and there are some customary scripts you can write that are easily supported by npm. When you first start off with a default package.json file created by npm init, this is roughly what the script section will look like. It'll have a default test script that when run will simply echo out that no tests are specified, and then exit. Let's first look at how to run scripts, and the two main default scripts that npm supports. We'll start with our test script. In order to run the test script, you simply type in npm test. That executes the script which we saw, which simply prints out of the console, npm err test failed. Now if we want the script to actually do something, we can go in and change the script itself. So in our case, let's run our test file by typing node space test.js, which will execute the test.js file in node. And now if we go out and run the same script, we can see that it's run our test script, which prints out that 5 of 5 tests have been run and 0 failures. Now, of course, in a more typical project, you'll probably be running something like Karma, in which case you can put the Karma command here inside the test script. The next script you want to create is the start script. This is the other default script that you will commonly see in most projects. By convention, the start script is the script that you'll run in order to launch the project. In our case, we want to run our index.js file with node, so we'll just use the script node index.js. And now if we run npm start, it will execute our index.js file, which prints out two messages, let's go to Mars and hello Mars. Again, in a more typical project, you might do something like launch HTTP server, telling it what port and subdirectory to start from, or maybe even live server, or something to that effect. These are two of the default supported scripts and the two most common ones that you want to use. There's actually a large set of other script names that are supported besides just test and start, and you can see that list here in the npm documentation. There's quite a few here, but by far most of these are not scripts that you're going to use yourself. In most cases, you're only going to be using test and start, and then you'll be using your own custom script names. For example, if you wanted a special script that would uglify your code, you could put in key uglify, and then a script for that. In this case, we use gulp compress, which uses gulp's uglify task. I've already specified the necessary information in my gulp file, which we can see here. This is just a very simple compress task. And now if I want to run this task, I'll go back to the command line, but instead of typing in npm uglify, which is how we might think we call the script, instead we have to use npm run, and then the name of the script, which runs the compressed task in gulp, which then creates this dist folder that has compressed our index.js file, and you can see that here. Now you might look at this and say, well, if I'm going to type in npm run uglify from the command line, I can instead just type in gulp compress, which is what ultimately gets run. So why bother with a longer command? Well, that's true to a point, but remember, this script section inside of your package.json file is a central place for all the scripts that you need, and they're all right together, one line after the next. That way, somebody doesn't have to go into your gulp file, look through it, and find the task that they want to use. You can give them prompts by creating the script section inside of your package.json file. And of course, if you're not even using gulp at all, then you can still do a lot of simple tasks using simple commands like the ones that we've seen here. Now that we know how to write our own scripts in order to run the various utilities that we might have in our project, it's also useful to talk about npx. Sometimes we need to run a utility, but we don't necessarily want to take the effort to write a script for it. Let's say in our little project here that we've got a file that we want to run a little linting on. I'm going to install jshint. Now that I have jshint, if I want to run that, jshint is a command line tool, but if I just run jshint from the command line and type in the name of the JavaScript file I want to lint over, it's going to error out on me and tell me that the command is not found. If I go over to the package.json file, I can write a script to run the jshint command, but I might not want to take that effort. So instead I can just run npx jshint server.js, and that will actually run jshint. We can see the output there. I've got 3 lines and I'm missing semicolons, and now that's useful for me and I can go on. So that's what npx is for, is to run those utilities that have command lines, but you don't actually want to write a script for them. Now, you may or may not have noticed before, but NPM runs a security check on the packages that you have installed. What it does is it actually checks the packages you have installed against a database of known security vulnerabilities that rates each of the vulnerabilities at low, medium, or high. So let's see an example of this. We're going to install Express, but I'm going to install a specific version. I'm going to get a slightly older version, 4.1.x. That'll be the latest version of 4.1. And we can see down here that after installed that, it's found 21 vulnerabilities, and it tells us how many of each: 8 low vulnerabilities, 6 moderate, and 7 high. And then it even tells us exactly what to do. It tells you to either run npm audit fix to fix them, or npm audit for details. Let's start by running npm audit and see what the output is. And it's this really long output where it tells you each item, what the rating is, what the actual vulnerability that was found was, what package it was in, what package that's a dependency of. You can see that here in this last one, and even tells you a recommended way to fix that one vulnerability. But for the most part, if you just run npm audit fix, npm will go ahead and try to update to the latest versions of all these various things and fix the issues. And so in this case, Express has fixed all of its issues in its latest version, at least all the known issues. And so we see the message down here that we have fixed 21 of 21 vulnerabilities in all the packages. Now, occasionally that doesn't actually happen. In fact, you'll usually find that you won't be able to fix all your vulnerabilities, but certainly trying to get the high ones fixed is very important. Now, how to address it if npm audit fix doesn't fix everything, which is very common, is well beyond the scope of this course. But you can check out my other course on addressing security vulnerabilities in npm with npm audit, also here on Pluralsight. In order to get ready to publish with NPM, you've got to prepare your user for publishing. For most people, that means they'll actually have to create a user account with NPM first. In order to do that, you go to npmjs.com and click sign up. From here, simply follow the prompts in order to create your user account. And be sure to remember your username and password. At that point, you can go out to your command line, and you'll need to add the user using the npm add user command. Executing this will prompt you to type in your username, your password, and enter your email address. Once you've done all that, it will add an npm authentication token to your npm RC file. And your user is now set up, and you can begin publishing packages. In order to get your project ready for publishing, you've got to do two main steps. One is set up your project in Git, and two is create the package.json file. We'll start off by setting up our project for Git. Right now, my project is blank. All it's got is my index.js file. So I'm going to create a Git repository for this using Git init. Now I've got my repository created. You may have already done this step yourself. In my case, I've already created my GitHub repository. But if you haven't created your repository, you simply go to your GitHub page and create a new repository for the project that you're going to be creating, fill in the name and description, and click the Create Repository button. If you're not familiar with GitHub, you can check out one of Pluralsight's courses on using GitHub. Once the repository is created, you'll need to associate your local files with that repository. And we do that using git remote add origin and the URL to the GitHub repo. In my case, this is my URL. Of course, yours will be different for whatever package you're creating. This is the critical piece we need set up before we create our package.json file, which I'm going to do next using npm init. Now this time through npm init, I've really got to pay attention to every question asked because they really matter when you're creating a package that you're going to be publishing. So the name matters because that's going to be its name in npm, and that's going to be the name that people use when they want to install using npm install. In my case, hello-mars is just great. The version can really matter. If you are in pre-release, you may want to start with a 0.1.0 or something like that. Although 1.0.0 is really just fine, so I'm going to go with that. I'll give it a description. And for the entry point, if this is a module that's going to be consumed by other people, which it typically is when you're publishing with npm, then you really need to make sure that you get the right entry point. Of course, mine is index.js, so I'll leave that as the default. For a test command, I don't have tests, but your project may have tests, in which case you want to put in what your test command is. The Git repository is automatically filled in for me. I can override this if this isn't correct. And a list of keywords, I'm just going to put in Mars. For the author, fill in my name. And finally, for license, I'll accept the default. And now it prints out to me what my package.json file is going to look like. I can double check it all, make sure it all looks good, and then hit OK. And now I've got my package.json file created, and my project is ready for publishing. Of course, if you walk through these same steps that I have, you're going to probably want to check in all your files and push them up anyway, with a git add dot, git commit -m, and your comment, and then a git push. If you haven't set your upstream like I haven't, you'll want to git push origin master. And now our project is set up and ready for publishing. Publishing our project is a really simple matter of just using the npm publish command. Once we have our project all set up, npm publish is all we have to do in order to publish it to npm. And you can see that after I've executed that command, it's gone ahead and published my project. You'll also see the version number that you've published. Mine's set at 102, but yours will be set at whatever you've got in your package.json file. And now that we've got that published, we can do things like npm info with our package name. You can also use npm repo, and that'll take you to the repository for your project. And if you want to go to its npm site directly, you can do npm.im/name of your project, and it will take you to the package's homepage. Now, publishing to the package is great, but that's really only half the story, because your package was also on Git, and you want to release on Git that's the same as the version you just published to npm. So we'll go back to the command line to do that, and we're going to issue the git command git tag, and then the name of our version. In my case, it's 1.0.2. In your case, it'll be whatever version you just published. Now, only do this after you've already committed and pushed your changes to your files that you've published through npm. Issuing that will tag the release, and now you can push that tag up to GitHub using git push --tags. And now if we go back to GitHub, we can see that tag by clicking under the branches button, and there's both a branches and a tags tab. We'll click the tags tab, and we'll see our 102 tag. If I click on that, we can see this version 102 tag, and we'll also note that this is marked as a release in GitHub. So people who come to your repository for your package, wanting to look at the source, can come in here and find the associated release with the version they're working with. This is something you really must do in order to play nice with the ecosystem of npm. You don't want users coming over to your GitHub repository and not knowing what version of files match a version that they're using on npm. That will create problems not only for them, but also for you as they submit issues on GitHub. And that's the basic process for publishing. Just use the npm publish command, tag it, and push the tag up to GitHub. Publishing an update to a package is a really straightforward process. It basically involves three steps. First, making the changes to your code. Second, updating your version. And then three, walking through the same publish process that we did when we were publishing our package initially. So let's make a small change to our code. Let's assume that we're going to add an extra exclamation mark. We'll save that change, and we're going to need to update the version of our package. We can go directly to our package.json file and manually update the version by just changing it here. Now we need to look at the nature of the changes that we've made in order to understand which part of the version number we need to change. In our case, we haven't changed any functionality. There's no new functionality. We haven't broken anything. So this is more like a bug fix, in which case we're just going to change the revision or patch number. But if we had added new functionality, say we'd put in a language parameter here, and then based on the language, we're going to print out a different message to the console, then we might want to update the minor version, so long as we include a default so that if they don't pass in a language, then it still prints out a message. Now, if we made language required, we'd actually be breaking functionality, in which case we're going to want to update the major version. Now, we can do all this manually by just adjusting the package.json file, or we can let npm adjust the version number for us. So let's go back to our index, and we'll just make the one change that we're going to have two exclamation marks in our message. Then we'll go out to the command line, and we're going to commit our changes using git add dot, git commit. And now that we've got our changes committed, we can use the npm command version, which takes one of three options, either patch, meaning that we're going to change the patch number, or minor, meaning that we're going to change the minor version number, or major, meaning that we're going to change the major version number. In our case, we'll just change the patch number. And now you can see it's printed out version 1.0.3, and if we go back to our code and look at our package.json file, it's been updated automatically to 103. Now, if you've been following along closely, you may have noticed something. We checked in our changes to the index.js file, but we didn't check in any changes to the package.json file, yet we changed it. So if we go back out to the command line and we do a git status, you may expect to see the package.json has been changed. But we're going to see that our working area is clean, there's nothing to commit. Although you may notice that it says that we're ahead of origin by 2 commits. If we do a git log, you can see that our last 2 commits are fixed message commit, and after that is a commit with just the message of 1.0.3. So what's happened is npm itself has made a commit for us. The other thing that npm did for us is it actually tagged that version. So if we just do git tag, we can see that we've got our 1.02 and the v1.03 that npm created for us. There's a small difference in there. The npm uses a prefix of v. That's fine. For our purposes, that really doesn't matter. So let's go ahead and push our changes and add the --tags option. And then we'll push up our new tag for us. We've also got to issue just git push in order to push up the file changes. Note that those have to be done separately, unless you dig into Git and set a configuration parameter, but that's beyond the scope of this course. And now with everything pushed up to GitHub, we can simply issue npm publish. And we just released version 1.0.3 of our hello-mars package to npm. Finally, let's talk about releasing alpha and beta versions. Here I've made some changes to the code to actually support languages. The changes should be backwards compatible because even if you don't pass in a language, you're still going to get the default message we were getting before, but if you happen to pass in ES for Spanish, you're going to get hello Mars in Spanish. So I'd like to publish this, but I'm not really sure how this is going to be received. I'd like to let users try this out and give me feedback. So I want to release a beta version. Well, beta versions are well supported by NPM. You just have to follow the semantic versioning conventions. In this case, we're going to update this to 1.1.0, but we're also going to add a -beta.0. This version lets people know that the product is currently in beta, and this is the initial version of beta. As we adjust it and try new versions that are still in beta, we can increment 0 to 1 to 2. Now, NPM does not support adding beta to the version like this, so we have to do this manually. Let's save this change, and we'll go out to the command line, and I'm going to add those changes, and then commit them. And with changes committed, I also want to tag this in Git. And I'm going to give it the same version for the tag as I gave it inside of my package.json. And now I can push my changes and push up the tag. Now, just like publishing a regular version, I'm going to use npm publish, but I'm going to add on the -- tag with a label of beta. This is going to publish this version, but tag it as a beta version. Let's go ahead and do that, and then we'll talk about what that means. Tags are a really interesting feature that npm supports, and we can see their use when we install a version. So if we were to install Hello Mars using npm I hello-mars, we can use an @ and then a tag name, and in this case, it's going to be beta, and that would install the beta version of Hello Mars. If we use latest, there could be other tags that we could put in place of this, or we can use, of course, just a version number. But let's see where those tags come from. If we use npm info, we can see the information about that package. And if we scroll up a little bit and look at this dist-tags key, you can see two entries. There's latest, which is set at 1.0.3, and beta set at 110-beta0. By default, whenever we publish a version, npm will update our latest tag with that version. But if we specifically tag it when we publish, then it will create that tag or update that tag to whatever version we're publishing. So by default, every package already has a latest tag, but we can add our own tags like we did with the beta tag. Now, of course, it's conventional to use beta, but we could use any tag that we wanted. We could call this trial or test. Of course, stay away from non-standard names like that. Alpha and beta are the kinds of tags that you want to use. Things other than that are really not conventional, and you should stay away from them. So now, if we were to go out to our trip to Mars, and we were to npm install hello Mars, and put the @latest tag, then you can see that we've installed Hello Mars version 1.0.3. This is exactly the same as just npm installing Hello Mars without the latest tag. But if we want to specifically install the latest beta version, we add the @beta tag. You can see that we've installed Hello Mars 110 beta version. This is showing up as invalid because it doesn't match our dependency specification inside our package.json file, which we can fix by going to our trip to Mars and adding in this version number 1.10-beta.0. And now if we list this out, it shows up without the invalid flag. So this is how you can publish beta versions of your package to npm. In this course, we learned the complete scope of npm, its features, how to use it on both large and small development projects, and how to use it to publish our own packages to the npm repository. Here are the key takeaways from this course. Just knowing npm install is often the only thing you need to know how to do. The key syntax to understand is the meaning of the caret and the tilde, and the difference between them when listing version numbers in your package.json file. And finally, the package.lock.json overrides the package.json file when doing npm install. Thank you for taking the time to go through this course. I hope you gained a lot from it. Please reach out to me on social media and say hi and tell me what you thought of the course. I'd love to hear from you.